So hello friends, welcome again to my YouTube channel, and today we are going to solve a new question from our top interview 150 question series. And today's question title is longest consecutive sequence. So let's understand this question. So what we have been given is a array of integers, and it is required to return the length of the longest consecutive element sequence. That means, for example, in this here you can see in nums integer array that the longest consecutive sequence of elements present in here is 1, 2, 3, and 4. So this is the length of the longest consecutive sequence. So we returned 4. Similarly, in this example second, you can see that the longest possible sequence, which is consecutive, is going to be 9. So it has returned 9. So we have to find different approaches, and at last we have also given that we have must write an algorithm that runs in big O of n time. So let's understand different approaches and try to find out a algorithm which runs in big O of n time. So these are the two example which I have taken. Now let's understand what is happening in this both example. So in the first example, you can see that the possible continuous sequence is our 1, 2, 3, and 4. This is the continuous sequence which is possible in the first case, and there is no other continuous possible because the others are 100 and 200. These two are not in continuous. So our output is going to be 4 in this case because the longest possible continuous sequence is 1, 2, 3, 4. But in the second example, you can see that what is happened that we have two sequence now. First is 1, 2, 3, 4, and we have another second sequence, and this sequence is our 100, 101, and 102. So these are the two continuous sequence which is possible, and the maximum length from them is going to be the first one. So we will return 4 in this case. Now let's understand how we can think of solving this problem. So let's first understand the brute force approach, how we can solve this. So what you can do is that in this nums integer array, you can start iterating from for each and every index. For example, if you take the 100, what you can do is that you can check for the 101. That means you will search for 101 if it is present in the other in this given input array or not. So if it is present, that means it is a part of a sequence. So what you can do, you can increase your current count, which is going to be for each and every index. So for our first index, you have increased your count to 2. Now again, when you are able to find 101, you again increase it and you will increase it to 102, and you will again search again in our nums integer array, and you again increase your count. So length is going to be 3 in this case if you start. So in the first, when you took the first index element which is 100, the length which you are able to accomplish is going to be 3, because at the first you already have 1, so you have started with 1. So when you are able to find 101, so you have increased your count to 2. When you are able to find 102, you increase your count to 3. When you are again increase it to 103 and you search, you are not able to find. So what you will do, you will move to the next index. Our You can update your global answer, which is going to be your global maximum, to 3, because initially it is going to be 1. Now again, when you are at the second, that means now what you are going to do is that you are starting for the second. So when you are starting for the second, which is 4, what you can do is that you can increase your value, which is going to be 5, and you try to check if 5 is present in the integer array or not, and you can see that 5 is not present. So your current maximum is 1, but your global is now updated to 3. So maximum is not going to change, your global is going to be 3 only. So we are stick with our maximum which we have found, which is 3. Now again, we you start from 101, and this time you will find 102 but not 3. So again it is going to be maximum 2. So there is no change in global. Now next time when you start with 1, here what happens is that you are able to find 2, you are able to find 3, and you are able to find 4. So in this case, what happens that your current is going to be increased to 4. Now your current is 4 and your global is 3. So you will update your current, your global, and it is going to be 4. So by using this loop, in which generally you are using two for loops, one for iterating for each and every index, and second is going to iterate in again for every index. So time complexity is going to be n square, because every index you are going to search. So by using this approach, what you are able to accomplish is that you are able to find the maximum length. So our problem is solved. But the question is asking you to find the solution in n, but we have found it in n square. Now let's optimize it. So next, what we can do, what you can think of is that you can clearly see that what we are talking about is we are talking about consecutive numbers. And whenever you are talking about consecutive number, one thing which will come to your mind is that why not sort this array. So if you sort it, you will get 1, 2, 3, 4, 100, 101, 102. So this is the sorted integer array which you will got. And what is the benefit using this? So the benefit is very clear to you, that we have accomplished that all the value which is going, we are going to find by iterating through the loop. We are now able to accomplish it by consecutive. That means they are now accumulated at a single point. They are close to each other. Now the searching is going to be easy, and that's how you can reduce the loop. So in here, what you can do, you can start from the first index, and you can check if the next one is greater than one or plus one or not. That means one plus one two, two plus one three, three plus one four. Until you are able to find, you will increase your current, and you can update your global. Up when you are not able to, that means if let's assume that you are at the four, and next you are trying to find five, and you are not able to find. So that means you stop at this point, and you can move to the next loop in which you will update your global value. And next, when you start from the 100, you will again initialize your current is equals to 1. That means you again start iterating, and you increase your current count. And after that, by using this, you will traverse through the whole integer array nums, and you will update your global count whenever you are not able to find the next index. So this is going to be a simple approach, and here the time complexity is going to be less. It is going to be n log n log n. And why is that? Because you have uses the sort. That means you have sorted the integer array. Its time complexity is going to be n log n. So what we have done, that we have reduced your n square to n log n, but until now we are not able to find n solution. Now let's try to think of the solution which will solve this question in n time complexity. So what you can do is that to solve this question is that you can store this in a set. So what we are going to do is that we are going to store all the elements in a set data structure. So basically what we can do is that we can take a set data structure of type int, and we will store all the values. And after storing this, so let's assume we have taken an ordered set. So it will be stored like this: 100, 4, 101, 1, 102, 3, and 2. Now we have stored all the values in our set. Now what we need to do is that we need to traverse in the set, and whenever we are at any position, we are going to check that if the previous one exists or not. If the 99 for 100, if 91 exists in this set, then what it means, that it is in between. That means 100 is in between our sequence. The sequence which is our the consecutive sequence, the 100 is in between. So if 100 is in between, then it is not going to give us the maximum value. So what we are going to do, we are going to skip it, because in the future or in past we already have traversed using this start node, or we are going to traverse. So it is not necessary to traverse again for 100. So basically what we are doing is that we are checking that if any value is in between our consecutive sequence or not. If it is in between consecutive sequence, then we can escape it. So we will do same. That means we will check if previous one exists or not. So here you can see that 101 previous is 99, which is not present. So maybe this could be a value which is going to give us the maximum output. So we are going to search for this. So we will search for this 101, 102. We will get our count is going to be 3. We will store it, and we will update our global. Now again, when you are at 4, you will check if 3 is present or not, and you will get to know that 3 is already present. So we can skip it, because it is never going to give us the maximum, because maybe 3 is going to give us the maximum. That's why. Again, when you are at 101, you will check if previous present or not. You will know that 100 is present. That means you can skip it. Now when you are at 1, you will see that my 0 is not present. So if 0 is not present, that means this could be a value which is the starting position of that consecutive sequence, which will give us the maximum. So we will traverse for this, and we will check if 2 is present or not. You will check yes, present. Again 3, again 4, and when you check 5, it is not present. So this time you get a count equals to 4. And now in previous we have 3. So now we update our maximum is equals to 4. So till now our maximum is 4. Again when you move to 102, again you will check its previous 101, it is present, that means you have to skip it. Again when you are at 3, you will check 2 is present, that means you will skip it. Again when you are at 2, you will check 1 is present or not, it is present, so you will skip it. So this is the algorithm which is going to help us to reduce the time complexity and the loops which we are going to utilize to find the count. So this is the most optimal approach, and its time complexity is going to be big of big of n. So its time complexity is now favorable to what is asked in this question. So you can clearly see that the set data structure is has helped us to reduce the time complexity. So it is a very important data structure. So now let's implement it and code it. Now as discussed, what we need to do is that we need to take an ordered set. So we are going to do the same, an ordered set of type int. Let's name it as. Now we are going to run a for loop in our vector I is equal to 0, I less than nums dot size I plus plus. Now in this what we have to do is that we have to populate our set. So we will write s dot insert our num size. Now let's initialize a variable which is answer, which is going to be 1, which is going to be our global count. Now we are going to traverse in our set. So we are going to write auto I in our set. So in here what we are going to check, first we are going to check that if our previous is present or not, that what we are doing. So we can check it by s dot find I minus 1. If it is equals to s dot end, that means we are not able to find it. So this time we have to traverse for the next ones. So what we need to do is that we need to initialize, let's initialize j is equals to I, and let's run a while loop, and this while loop is going to check that if we are able to find next or not. So we can check s dot find j plus 1 is not equals to s dot end. So if we are able to find the next, what we need to do is that we need to increase our local count. So let's declare a local count also, count equals to 1. So what we need to update our count. So we are adding count plus plus. Now what we need to do, we need to increase our j for taking for the next ones. Now after this we will update our answer is equals to max of ns comma count. Now after this we will simply return our answer. One thing to notice is that our nums dot length could be equals to 0. So if when it is equals to 0, then our answer is again going to be 1, but it is not correct. That means if it is 0, then answer should be also equals to 0. So for this we will tackle this corner case and we will check if our nums dot size is equals to 0. We will simply return 0. Now let's try to run this code. So this is accepted. Now let's submit this code. So this is successfully submitted. So this is the question for today, and this is a very interesting question, and we have learned different approaches and different solutions to get. First, we have seen that we have solved in n square, then we optimized to n log n, and finally we have achieved log n n's time complexity by using unordered set. So you will get to see the solution of Java and Python both in the same video. Now let's meet up in the next video. Till now, stay tuned and keep learning. Thank you.